Now, dividing expressions. This is where things get interesting. Dividing rational expressions is an extremely complicated procedure, so you need to pay very close attention to this. Maybe replay it a couple of times. Okay. Make sure you're ready to take notes. Here we go. To divide rational expressions, you start by multiplying by the reciprocal. Once you've multiplied by the reciprocal, well, that's it. That's all you do. It's not complicated. It's not scary. It's not confusing at all. Just like any other fraction, 1/2 divided by 3/4, you multiply by the reciprocal, make it 4/3, and then cross cancel and solve. Okay. The same thing is true here. We're just going to multiply by the reciprocal. So let's pop over here to our paint program again. No, we don't need to save it. And let's say we have we'll just keep using the same stuff here. It just makes it so much easier. X squared minus 1 over x, let's say 4x cubed plus 2x squared divided by, let's make it I don't need a parenthesis there. Let's see, what should I have there? Let's have x squared plus 3x plus 2 over, let's make it a 2x squared minus, make it cubed. I'll make it to the 4th even. 2x to the 4th minus 8x squared. Alright, there's our problem. So squared won't be any fun. Let's make it a little bit more interesting here. I'll make it 5 and cubed. There we go. That's better. Alright, the first step in dividing rational expressions is to multiply by the reciprocal. So we turn the division into multiplication, and then we do the reciprocal. And you may remember from your work with fractions before that reciprocal just means to flip that over. Okay? So, and I always do it right there on my work. I put this down here, x squared plus 3x plus 2. Okay, and then this comes up, so that's going to be 2x to the 5th minus 8x cubed. Okay, boom, we just multiplied by the reciprocal. And that's really all there is to division, because look at what we have now. We have a multiplication of rational expressions problem. And so we handle it just like we did all the other multiplication of rational expressions problems. What do? We factored the numerators. So that's going to give us an x minus 1 and an x plus 1. Okay. We've got a common 2x cubed. That comes out, leaves us with x squared minus 4. So that's done, but this can be factored more, so we need to factor that down some more. That's going to be, we still have the 2x cubed out. Now we have an x minus 2 and an x plus 2. Okay. I usually like to keep going vertical, but I ran out of space here, so that's done. Factor the numerators, factor the denominators. We have a common 2x squared here. So that's going to be 2x plus 1. So that's done. And then this is the factors of 2 that add to be 3 are x plus 2 and x plus 1. Okay. So we multiplied by the reciprocals, turned the division into multiplication, then we factored the numerators, factored the denominators, and cancel common. Factors, x plus 1 cancels. X plus 2 cancels. We have a 2 that cancels. We have x squared and x cubed. We can cancel 2 of the x's this time. This has 3 x's, so again we can just hit that 3, and so now we only have 1 x remaining up there. And so then what's left? We have the x and an x minus 1 and an x minus 2. This becomes the hard part, is finding what's left. You got the x minus 1, we got the x right there, and we have the x minus 2. Sometimes it can be hard to find it after you have all that crossing out. So search carefully, work as organized as neatly as you can so that they're easier to find. And then all we have in the denominator left is the 2x plus 1. Okay. There it is. And then that would be your answer. Alright? Alright, let's pop back over here. That's dividing. That's all there is to it. Okay. Converting units. This is done quite often in your chemistry classes or your biology classes. Many of you have probably done it already. One of the science teachers has asked me for a copy of this portion of the video for her classes, because it's such an important part of your science classes. So if you're taking a science class, maybe you'll see this part again. Here's your converting units process. Write down what you have. Let's say you're you want to convert miles per hour into feet per second. So you already have miles per hour. You know that you drove 20 miles an hour. Okay? You have 20 miles an hour. So you write that down, 20 miles per hour. Then you write down what you want. You want feet per second. Okay? That's going to become your guide then. You have miles per hour. Write that down on the left side of a piece of paper. You want feet per second. You write that down on the right side of a piece of paper. You want to go from the left, miles per hour, to the right, feet per second. That becomes your guide. Then anything that is not in what you want to get rid of, right? Because you don't want it anymore. So you place the conversion factors to cancel out what you don't want. Don't worry about trying to get what you do want. Focus on getting rid of what you don't want. That's the easiest way to keep track of what you need to do and when you need to do it. Okay? And then you just cancel and multiply. So let's take a look at that. Pop over here to our paint program. New screen. No. Okay. Let's use the example I mentioned. Alright, so we have 20 miles per hour. 20 miles for 1 hour. Every hour you drive 20 miles. Okay? Over here we want feet per second. That's what we want. We want to go from here to there. So we don't want miles in our answer. Okay, we don't want miles in our conversion. So we want to get rid of miles. So we're going to multiply it by a rational expression that's going to cancel out the miles. Now if miles are up here in the numerator, how are you going to cancel them out? By having miles in the denominator, right? Remember, numerator, denominator cancels. So we're going to put miles in the denominator. Now what are we going to turn miles into? Well, we could turn them into yards, but we don't want yards, do we? We want feet. So let's just go ahead and turn them into feet. Okay? So the miles are gone, and then we're going to have feet. But we don't want an hour in our conversion either, so we need to get rid of that. So we'll multiply that, continue multiplying. We want to get rid of the hour. If the hour is in the denominator, how are we going to cancel it? By putting hour in the numerator. Okay? And then what are we going to turn it into? Well, you could go straight to seconds, but that's going to be quite a large conversion. So why don't we take a step in the middle and do minutes? Convert hours into minutes. Okay? But we still don't want minutes in our final conversion, so now we'll get rid of the minutes. And again, it's in the numerator, so to get rid of it, we'll put it, it's in the denominator, so to get rid of it, we'll put it in the denominator. In the numerator, it's in the denominator, we'll put it in the numerator, that way they'll cancel. Oh my goodness. Alright. And then what are we going to turn that into? We're going to turn that into seconds. Okay. put the units in place first and then test them by canceling. Miles will cancel with miles. Hour will cancel with hour. Minute will cancel with minute, leaving me with feet per second. Once I have all that in place, now I know for a fact that I have that my conversion is going to work. Okay, I haven't even done anything with the numbers yet, but I know that it's all going to work because my conversions are my units are working. Therefore, the numbers will work. The hardest part I have with converting units is: am I supposed to multiply to get the number bigger, or am I supposed to divide to get the number smaller? If the unit gets bigger, the number needs to get smaller, right? 1 yard is 3 feet. So when the unit got smaller, feet are smaller than yards, the number got bigger. 3 is bigger than 1. So, 1 yard is 3 feet. But how to keep track of that in your head, for me, is difficult. But this is perfect because I don't need to keep track of what do I multiply and what do I divide. All I want to do is get rid of miles and turn them into feet. Get rid of hours, turn them into minutes. Get rid of minutes, turn them into seconds. Once I have all my units going the way I want them to, then all I have to do is fill in the numbers. 1 mile is 5,280 feet. If you don't know that, you should. That's a good conversion to have in your head on a regular basis. 1 mile is 5,280 feet. 1 hour is 60 minutes. 1 minute is 60 seconds. Okay? Now I already know what to do with my numbers because all my units I've already taken care of where to put everything. I'm going to multiply by 5,280, and I'm going to divide by 60 and divide by 60 again. You could punch it in your calculator even. You could multiply the top, multiply the bottom, and then divide. Or you could cancel. This is what I prefer to do because I very seldom have a calculator on me. The 0 means it's been multiplied by 10, so I can hit 10 on both of them. I can hit this 0 and this 0. I can hit this 2 and this 6 and leave it with 3. 5 plus 2 plus 8 is 15, so that's divisible by 3. So I can hit that and this 3 and leave us with 176. Okay. That's not divisible by 3 anymore, but it is divisible by 2. It's odd. It's even, so I can hit that and this and get a 2 out of those. That's going to leave me with 88. Okay. And so then when it's all said and done, all I need to do is divide 88 by 3. So 88 divided by 3 would be 2 with 2 left over, 9, 29 and 1/3 feet per second. That would be my answer. 29 and 1/3 feet per second. Here's this is, if you're using the slanted divisor bar as a part of a unit, I guess it's not horrible, but I'm not a big fan of slanted divisor bars. I can't even make them very well. See, all right. So that's feet per second. Okay. Now, whether or not you want to cancel all the numbers like I did or punch the numbers into a calculator is your business. But the point is that by working the units first, then you can know that all the numbers are correct. Anything on the top gets multiplied, anything on the bottom gets divided. It's just that simple. Okay? Alright. Well, that's the end of our lecture. That carries us through 7.1 and 7.2. Simplifying rational expressions. Rational expressions are anything that can be written as a fraction. So basically reducing fractions. Multiplying was essentially the exact same thing, as simplifying. Dividing was just multiply by the reciprocal and turn it into a multiplication problem. And then the converting units focus on getting rid of what you don't want and leaving what you do. Okay? So if you have any questions, write them down, bring them to class, and we'll make sure that we answer as many as we possibly can. Thank you.